Bismillahirrahmanirrahim. Assalamu alaikum dear students. You are watching Study with Sir Sheraz, and in today's lecture we are going to discuss about the applications of the Fajans rule. We have a previous lecture in which we discussed about the Fajans rule. So if you have not watched that lecture, so first go and watch that lecture so you can have a better understanding of the applications. The link of that lecture is provided in the description section of this video, and that video is also present at the end screen. So first of all, in order to extensively discuss about the polarizing power of the cation, we have devised a term, and that term is basically called the ionic potential of the cations. It's basically the charge density of the cations, and it's shown by the symbol phi. So phi, or the ionic potential of cation, is equal to the charge of cation divided by the radius of cation. From now to onward, we will discuss about the polarizing power of the cations in terms of the phi value. First application of the Fajans rule is the covalent character of the ionic compounds. Basically, using these rules we can find out the covalent characters that is present in the ionic compounds. Larger the value of phi, greater would be the covalent character in the ionic compound. So if we are having two salts and we are asked which salt would be having the more ionic character or which salt would be having the more covalent character, so we have to find out the phi value. The cation whose phi value is greater would be having much polarizing power, and that would cause a greater covalent character within a salt. How the covalent character is produced? Basically, whenever a cation polarizes or distorts the electronic cloud of the anion, a covalent character is produced in the salt, and that leads to the formation of lesser ionic character or the more covalent character. So keep in mind that we are discussing about the ionic character and covalent character. So greater polarizing power of the cation causes greater covalent character in the salt. If we have two salts, that is NaCl and AlCl3, and we are asked to compare their covalent character, or we are asked to compare their ionic character, so keep in mind that the size of Al plus 3 is much smaller as compared to size of the sodium ion. We have to find out the cation in both salts. Here the cation would be Al plus 3, and here it is the Na plus. Phi value for the aluminium plus 3 would be greater as compared to that of the sodium plus. So the covalent character would be greater in aluminium chloride as compared to that of the sodium chloride. The point number 2 is very much important as the salts and ionic compounds are concerned. Melting points of salt. We are given two or more salts and we are asked that which of the salt would be having the greater melting point and which would be having smaller melting point. So keep in mind that greater the ionic character in a salt, greater would be its melting point. So now we can predict which salt would be having the greater melting point, which would be having the smaller melting point. We are given two salts, sodium chloride and aluminium chloride. Can we predict which of these salts would be having the greater melting point? Aluminium ion in plus 3 state. So here the phi value would be greater as compared to that of sodium. So this salt would be having more covalent character as compared to that of the sodium chloride. So if sodium chloride is having a smaller covalent character, it is having a larger ionic character. So its melting point would be higher as compared to that of aluminium chloride, and that is evident from the literature value. The melting point of the sodium chloride is 800, whereas the melting point of the aluminium chloride is 180. So there is a marked difference between the melting points of both these salts. Point number 3 is the complex formation. Complexes are basically an important class of compound that are discussed in coordination chemistry. So basically many type of the cations form the coordination compound, but the tendency of coordination compound depends upon the polarizing power or the phi value of the cation. Greater the polarizing power of the cation, greater would be its tendency to form the complex. So greater phi value, more complex formation. Transition metal cations are having more polarizing power as compared to that of the typical metal. So transition metal are specialized group of elements that are specialized for forming the coordination compound. Degree of hydration. So higher phi values, greater hydration tendency. If we are given two cations and we are asked to compare their hydration powers, so keep in mind the cation having greater phi value would be having the greater tendency to attract and to orient water molecules around its sphere to form the hydrate. So greater hydration is shown by the cations having the greater phi value. Point number 5 is very much important at paper point of view, thermal stability. We are given different salts and we are asked to compare their thermal stability, especially the thermal stability of the carbonates is compared. So greater phi value, lesser would be the thermal stability, because greater phi value leads to the greater covalent character and greater covalent character leads to the lesser, or you can say the weaker thermal stability of the carbonates. So if we are given the number of carbonates are here and we are asked to compare their thermal stability, so this order is given that beryllium carbonate is the least stable, then magnesium carbonate, calcium carbonate, strontium carbonate and barium carbonate. So barium carbonate is most stable and beryllium carbonate is least stable. Why this is happening? Because all these metals belong to the group 2 of the periodic table, and down the group the value of polarizing power decreases. So beryllium carbonate would be having the highest phi value, whereas barium plus 2 would be having the smallest value. So that's why the covalent character of beryllium carbonate is highest. So and if we talk about the barium carbonate, its ionic character is greatest, so its melting point and thermal stability would be greatest of all. Next point is the solubility of compounds. So solubility of compounds can also be discussed in terms of the polarizing power and covalent character of the salts. More covalent character of the salt, lesser solubility in water. So if we are given 2 or more salts and we are asked to compare their solubility in water, so keep in mind that the salt having higher covalent character would be less soluble in water, and that with more ionic character would be more soluble. We can compare the solubility of sodium chloride and aluminum chloride in water. So sodium chloride is having smaller covalent character, more ionic character, so that's why the water solubility of sodium chloride would be greatest as compared to that of the aluminum chloride. Here solubility of the sulfides and oxides is compared, as the polarizability of sulfide ion is more as compared to that of the oxide. So now we are going to discuss about the polarizability of anion. So if we are having the same metal, once it is forming the oxide, at the other time it is making the sulfide. So oxide of a metal would be more soluble in water because of the lesser covalent character, whereas the sulfide would be lesser soluble in water because of its higher covalent character. Last point is the diagonal relationship. So comparison of the phi values allows us to establish a diagonal relationship between the elements of group period number 2 and period number 3. So beryllium plus 2 has same phi value as compared to aluminium. So beryllium is having that diagonal relationship with the aluminium plus 3. Basically diagonal relationship is a very important concept in the chemistry, and we would be having a separate video on that. So you people must watch that video in order to understand what is diagonal relationship. This was all about the applications of Fajans rule. If you are having any question related to this lecture, you can post your question in the comment section. We will meet in the next video. Till then, Allah Hafiz.